Hello everyone. I am Dr. Sharad Kumar, Assistant Professor, Department of Wildlife Sciences, Aligarh Muslim University. Climate change and global warming are the global problems having adverse effect on our environment and posing challenge to the well-being of living organisms. Having awareness about these problems is necessary to garner the support of people for implementation of strategies to mitigate these problems. In this lecture, I shall be discussing about global warming and climate change, its causes and impacts. Global warming refers only to the Earth's rising surface temperature, while climate change includes warming and the side effects of warming, like melting glaciers, heavier rainstorms, or more frequent drought, etc. Let's first take the global warming. Global warming is referred to the gradual increase in the average temperature of the Earth. The sun is the primary source of energy to Earth. Some of the solar energy coming from sun is reflected back to sky, while remaining is absorbed at the lower surface of Earth and help in keeping the Earth warm. There is a delicate balance between the reflection and absorption of solar energy, and it is essential for existence of life on Earth. But human activities led to the increase in the absorption of heat at the lower surface of Earth, and in turn increasing the average temperature of Earth and causing global warming. Greenhouse effect. Let's understand how Earth keeps itself warm. The Earth maintains its temperature through the process of greenhouse effect. Troposphere, the lowermost layer of the atmosphere, traps heat by a natural process due to the presence of certain greenhouse gases. It is similar to the warming effect observed in the horticultural greenhouse made up of glass. The amount of heat trapped in the atmosphere depends mostly on the concentration of heat trapping or greenhouse gases and the length of the time they stay in the atmosphere. The major greenhouse gases are carbon dioxide, ozone, methane, nitrous oxide, chlorofluorocarbons, and water vapors. How greenhouse gas effect occur on Earth? On Earth, the greenhouse effect occurs when greenhouse gases in our planet's atmosphere trap some of the heat radiated from the planet's surface and leading to raising its temperature. This process happens because sun emits short-wave radiation that passes through greenhouse gases, but planet emits long-wave radiation that partly absorbed by greenhouse gases. The difference in coming and outgoing radiation reduces the rate at which our planet can cool off in response to being warmed by sun. So the difference in the wavelength of radiation coming from the sun and the radiation emitted from the earth is responsible for greenhouse effect. Adding to greenhouse gases further reduce the rate at which our planet emits radiation to space and lead to raising its average surface temperature. The average global temperature of Earth is 15 degrees Celsius. In the absence of greenhouse gases or greenhouse effect, this temperature would have been 18 degrees Celsius. Therefore, greenhouse effect contributes a temperature rise to the tune of 33 degrees Celsius. Heat trapped by greenhouse gases in the atmosphere keep the planet warm enough to allow us and other species to exist, and therefore greenhouse effect is essential for the evolution of life on Earth. The two prominent greenhouse gases are water vapor, which is controlled by hydrological cycle, and carbon dioxide, which is controlled by the global carbon cycle. While the level of water vapor in the atmosphere have relatively remained constant, the level of carbon dioxide have increased. Other gases whose level have increased due to human activities are methane, nitrogen oxide, and chlorofluorocarbon, and they are causing global warming. Concern of environmentalists. The concern of environmental scientists is that Due to the anthropogenic activities, there is increase in the concentration of the greenhouse gases in the air that absorb infrared light containing heat and result in the re-radiation of even more of the outgoing thermal infrared energy, thereby increasing the average surface temperature beyond 15 degrees Celsius. The phenomena is referred to as the enhanced greenhouse effect to distinguish its effect from the one that has been operating naturally for millennia. Warming or cooling by more than 2 degrees Celsius over the past few decades may prove to be disaster for various ecosystems on the earth, including humans, as it would alter the condition faster than some species could adapt or migrate. Some areas will become inhabitable because of drought or flood following a rise in average sea level. Greenhouse gases. Gases that trap heat in the atmosphere are called greenhouse gases. Some of the important greenhouse gases are as follows. Carbon dioxide. It constitutes about 77% to total global warming from greenhouse gases produced by human activity. Industrial countries account for about 76% of annual emissions. The main source are fossil fuel burning, which contributes around 67%, and deforestation and other forms of land clearing and burning, which contributes about 33%. CO2 stays in the atmosphere for about 700 years. Carbon dioxide concentration in the atmosphere was 377 ppm in 1990, that is increasing at a rate of 1.7 ppm every year. This is the Keeling curve. The Keeling curve, named after the American scientist Charles David Keeling, track changes in the concentration of carbon dioxide in Earth's atmosphere at a research station located at Mauna Loa in Hawaii. Despite a small seasonal fluctuation in carbon dioxide concentration, the overall trend shows that carbon dioxide is increasing in the atmosphere continuously. Chlorofluorocarbons. These are believed to be responsible for 24% of the human contribution to greenhouse gases. They also deplete ozone in the stratosphere. The main source of chlorofluorocarbons include leaking air conditioner and refrigerators, evaporation of industrial solvents, production of plastic foams, aerosols, propellants, etc. Chlorofluorocarbons take 10 to 17 years to reach the stratosphere and generally trap 1700 to 7000 times more heat per molecule than carbon dioxide while they are in the troposphere. The heating effect in the troposphere will be partially offset by the cooling caused when chlorofluorocarbons deplete ozone during their 67 to 100 years stay in the stratosphere. Atmosphere concentration of chlorofluorocarbons is 0.00227 ppm, that is increasing at a rate of 0.7% annually. Methane. It accounts for 18% of the increased greenhouse gases. Methane is produced when bacteria break down dead organic matter in moist places that lack oxygen, such as swamps, natural wetlands, paddy fields, landfills, and digestive tract of the cattle, sheep, and termites. Production and use of oil and natural gas and incomplete burning of organic material are significantly sources of methane. Methane stays in the atmosphere for 7 to 10 years. Each methane molecule traps about 27 times as much as heat as carbon dioxide molecule. Atmospheric concentration of methane is 1.677 ppm and it is increasing at a rate of 1.1% annually. Nitrogen oxide. It is responsible for 6% of the human input of greenhouse gases. Besides trapping heat in the troposphere, it also depletes ozone in the stratosphere. It is released from nylon products, from burning of biomass and nitrogen-rich fuels, especially coal, and from the breakdown of nitrogen fertilizers in soil, livestock wastes, and nitrate-contaminated groundwater. Its life in the troposphere is 140 to 190 years, and it traps about 230 times as much as heat per molecule as carbon dioxide. The atmospheric concentration of nitrogen oxides is 0.3 ppm, and it is increasing at a rate of 0.2% annually. Water vapor. Water vapor is the most potent greenhouse gas in Earth's atmosphere, but its behavior is fundamentally different from that of the other greenhouse gases. The primary role of water vapor is not as direct agent of radiative forcing, but rather as climate feedback. This distinction arises because the amount of water vapor in the atmosphere cannot, in general, be directly modified by human behavior, but is instead set by air temperature. The warmer the surface, the greater the evaporation rate of water from the surface. As a result, increased evaporation leads to a greater concentration of water vapor in the lower atmosphere, capable of absorbing infrared radiation and emitting it back to the surface and leading to the global warming. Global warming potential of greenhouse gases. Greenhouse gases warm the earth by absorbing energy and slowing the rate at which the energy escapes to space. They act like a blanket insulating the earth. Different greenhouse gases can have different effect on the earth's warming. Two key ways in which these gases differ from each other are their ability to absorb energy, means their radiative efficiency, and how long they stay in the atmosphere, also known as their lifetime. Global warming potential is a measure of how much energy the emission of 1 ton of a gas will absorb over a given period of time relative to the emission of 1 ton of carbon dioxide. The time period usually used for global warming potential is 100 years. The larger the global warming potential, the more that a given gas warms the earth compared to carbon dioxide over that time period. Global warming potential of different greenhouse gases for 100-year period. CO2 by definition has a global warming potential of 1 regardless of the time period used, because it is the gas being used as the reference. The global warming potential of methane is higher than the carbon dioxide, indicating its higher effect on the global warming. Similarly, chlorofluorocarbons and hydrochlorofluorocarbons also have higher global warming potential in comparison of carbon dioxide, but their concentration is very low in comparison of carbon dioxide. Now let's learn about the climate change. So first, try to understand what is climate change. Climate is the average weather condition of a particular geographic area for a long period of time, at least 30 years. Any significant change in average weather condition is recognized as climate change. According to United Nations, climate change is long-term shift in the temperature and weather patterns. Such shift can be natural, but for last few centuries, human activities have been the primary reason leading to the climate change. The Intergovernmental Panel on Climate Change published the evidences indicating shift in the global temperature and climatic patterns. Evidences of climate change. The evidences of climate change are visible everywhere around us, and they can be divided into physical evidences and biological evidences. The physical evidences of climate change include rise in atmospheric temperature of land and sea, shrinking and shifting of winter period, receding of glaciers, rise in sea level, change in spatial pattern of rainfall and temperature, decrease in the pH of seawater, and occurrence of climatic extremes and natural disaster, etc. Biological evidence of climate change include early blossoming on trees like mangoes, cherry, etc. Drastic increase in growth rate of grasses in Antarctic, geographical shifting of temperate fruits towards high latitudes, occurrence of chytrid-related diseases in amphibians, spatial shifting of marine fish populations, bleaching of corals, northward movements of ticks, etc. Causes of climate change. There are various reasons such as generation of power, production of good, etc., which are leading to climate change. Let's discuss them one by one. Generating power. Generating electricity and heat by burning fossil fuels causes a large chunk of global emissions. Most electricity is still generated by burning coal, oil, or gas, which produce carbon dioxide and nitrous oxides. These gases are powerful greenhouse gases that blanket the earth and trap the sun's heat. Manufacturing goods. Manufacturing and industry produce emissions mostly from burning fossil fuels to produce energy for making things like cement, iron, steel, electronics, plastics, clothes, and other goods. Mining and other industrial process also releases gases, as does the construction industry. Machines used in the manufacturing process often run on coal, oil, or gas, and some material like plastics are made from chemicals sourced from fossil fuels. The manufacturing industry is one of the largest contributors to greenhouse gas emissions worldwide. Cutting down forest. Cutting down forests to create agriculture fields or pastures or for other regions causes emissions since trees, when they are cut, release the carbon they have been storing. Each year, approximately 12 million hectares of forest are destroyed. Since forests absorb carbon dioxide, destroying them also limit nature's ability to keep emission out of the atmosphere. Deforestation, together with agriculture and other land use changes, is responsible for roughly a quarter of global greenhouse gas emissions. Using transportation, most motorcycles, cars, buses, trucks, ships, planes run on fossil fuels. That makes transportation a major contributor of greenhouse gases, especially carbon dioxide emissions. Road vehicles account for the largest part due to the combustion of petroleum-based products like gasoline in internal combustion engines. But emissions from ships and planes continue to grow. Transport accounts for nearly one quarter of global energy-related carbon dioxide emissions, and trends point to a significant increase in energy use for transport over the coming years. Producing food. Producing food causes emission of carbon dioxide, methane, and other greenhouse gases in various ways, including through deforestation and clearing of land for agriculture and grazing, digestion by cows and sheep, the production and use of fertilizers and manure for growing crops, and the use of energy to run farm equipment or fishing boats, usually with fossil fuels. Greenhouse gas emission also come from packaging and distributing food as consumption of packed food is increasing rapidly. All this makes food production is a major contributor to climate change. Powering buildings. Globally, residential and commercial buildings consume over half of the electricity as they contribute to draw on coal, oil, and natural gas for heating and cooling. They emit significant quantities of greenhouse gas emissions. Growing energy demand for heating and cooling with rising air conditioner and refrigerator ownership, as well as increased electricity consumption for lighting, appliances, and connected devices has contributed to a rise in energy related carbon dioxide emissions from buildings in recent years. Consuming too much. Your home and use of power, how you move around, and what you eat and how much you know throw away all contribute to greenhouse gas emissions. So does the consumption of goods such as clothing, electronics, and plastic. A large chunk of global greenhouse gas emissions are linked to private households. Our lifestyle have a profound impact on our planet. The wealthiest bear the greatest responsibility. The richest 1% of global population combined account for more greenhouse gas than the poorest 50%. Impact of climate change. Impact of climate change are visible everywhere around us like extreme weather, receding glaciers, extreme heat in summer, drought, fires and stress to ecosystem. Many of these impact will create hardship for humans and wild animals. Let's discuss them one by one. Hotter temperatures. As greenhouse gas concentration rise, so does the global surface temperature. The last decade, 2011 2020, is the warmest on record. Since the 1980s, each decade has been warmer than the previous one. Nearly all land areas are seeing more hot days and heat waves. Higher temperature increase heat-related illnesses and make working outdoor more difficult. Forest fires start more easily and spread more rapidly when conditions are hotter. Temperature in the Arctic have warmed at least twice as fast as the global average. Increased drought. Climate change is changing water availability, making it scarcer in more regions. Global warming exacerbates water shortages in already water-stressed regions and is leading to an increased risk of agricultural drought affecting crops and ecological droughts increasing the vulnerability of ecosystem. Drought can also stir destructive sand and dust storms that can move billions of tons of sand across continents. Deserts are expanding, reducing land for growing food. Many people now face the threat of not having enough water on regular basis. Ocean warming and rising. The ocean absorbs most of the heat from the global warming. The rate at which the ocean is warming is strongly increased over the past 2 decades across all depth of the oceans. As the ocean warms, its volume increases since water expands as it gets warmer. Melting ice sheet also cause sea levels to rise, threatening coastal and island communities. 1 meter rise in sea level will inundate low-lying areas of cities located near sea like Shanghai, Cairo, Bangkok, Sydney, Hamburg, and Venus, as well as agriculture lowlands and deltas in Egypt, Bangladesh, India, and China. In addition, the ocean absorbs carbon dioxide, keeping it from the atmosphere. But more carbon dioxide makes the ocean more acidic, which endangers marine life and coral reefs. Loss of species. Climate change poses risk to the survival of species on land and in the ocean. These risks increases as temperatures increase. The species extinction rate is exacerbated by climate change. The world is losing species at rate 1000 times greater than at any other time in recorded human history. 1 million species are at risk of becoming extinct with the next few decades. Forest fires, extreme weather, and invasive pests and diseases are among many threats related to climate change which are leading to loss of species. Some species will be able to relocate and survive, but others will not, and it leads to the extinction of the species. Reduced food productivity. Changes in the climate and increase in extreme weather events are among the reasons behind a global rise in hunger and poor nutrition. Fisheries, crops, and livestock may be destroyed or become less productive due to the climate change. With the ocean becoming more acidic, marine resources that feed millions of people are at risk. Changes in snow and ice cover in many Arctic regions have disrupted food supply from herding, hunting, and fishing. Heat stress can diminish water and grassland for grazing, causing declining crop yields and affecting livestock. Tropical and subtropical regions will be more affected since the average temperature in these regions is already on the higher side. Even a rise of 2 degrees Celsius may be quite harmful to crops. Soil moisture will decrease and evapotranspiration will increase, which may drastically affect wheat and maize production. Increase in temperature and humidity will increase pest growth, like the growth of vectors for various diseases. Pests will adapt to such changes better than the crops and have negative impact on the productivity. More health risk. Climate change is the single biggest health threat facing humanity. Climate impacts are already harming health through air pollution, disease, extreme weather events, forced displacement, pressure on mental health, and increased hunger and poor nutrition in places where people cannot grow or find sufficient food. Every year, environmental factors take the lives of around 13 million people. Changing weather patterns are expanding diseases and extreme weather events increase death and make it difficult for healthcare systems to keep it. Poverty and displacement. Climate change increases the factor that put and keep people in poverty. Floods may sweep away urban slums, destroying homes and livelihood, which is increasing the poverty. Heat can make it difficult to work in outdoor jobs. Water scarcity may affect crops and reduce the gain from agriculture and leads to poor farmers. Over the past decades, 2010 to 2019, weather-related events displayed an estimated 23.1 million people on average each year, leaving many more vulnerable to poverty. Most refugees come from countries that are most vulnerable and least ready to adapt to the impact of climate change. Measures to check global warming and climate change. By adopting various measures, we can check the global warming and climate change. Some of the measures are: cut down the current rate of use of fossil fuels and products releasing chlorofluorocarbons, use energy efficient machines and equipment, shift to renewable energy sources, increase nuclear power plant for electricity production, trap and use methane as a fuel, adopt sustainable agriculture, transport, urbanization and industrialization, stabilize population growth, efficiently remove carbon dioxide from smoke stacks, plant more trees, remove atmospheric carbon dioxide by utilizing photosynthetic algae. Thank you.